I'm Raz. I own a small agency that is concentrated on outsourcing, and we mainly use Flutter. I started off as an Android developer, then I started learning iOS, and then eventually Flutter came in, so here I am, Flutter. And because this is an Android conference, you're going to see a lot of Android code here, so it's going to be fun. So how many of you have ever used background code in a Flutter application, or needed to execute? Okay. That's okay. It's not very common, but there are use cases where you actually want to use it. So in this talk, we're going to see how we can use it, and what are the steps that we need to do to implement this. Let's talk first about why we want to do that. So background is very important. So maybe we want to display how many steps the user has walked, or we have like a media player app that we want to show the song, or we have like a huge file that we want to download, and we want to keep the download state. So we're going to show something to the user that we are doing that, and we want to do that in background. That's very important. So there are two types of work that we can do here. So work that the user is aware of, and we want to show something to the user, or work that is deferred. For example, we want to synchronize with a database. We just want to show the user that we did that when he opens the app, but not explicitly saying that. But on the other cases, when the user needs to be informed, we want to show something that is visual for him. And it's been very important for a long time to have this ability. It's true that developers have not been very good developers or citizens of Android platform, and we're going to see in a bit why. So the thing is that a lot of talk about Flutter, or reason why Flutter is not very good, is because it doesn't allow you to do background stuff. But it's not really Flutter's job to allow you to do that. So as we know, Flutter just runs as a normal application on top of whatever exists. In Android, it would be a normal Android app. You have an activity that starts up the Flutter engine for you and does all the stuff. But it's not the choice of Flutter, or Flutter cannot control if the app runs or not. Right? The OS or the user is the one that will tell, okay, I want to start this. So same with background. So it's really the OS job to dictate when you can run or what you can do. And historically, developers have been running services in background indefinitely for a very long time, draining the battery and internet connection of the users. So Google and Apple said, no, don't do that. And then developers didn't listen, and then they put on a lot of restrictions. And now developers are listening. So what we need to do here is to listen to the system. When are we allowed to? It's not a Flutter question, but when does the OS let me do background work? What kind of background work can I do? So this is the question. These are the questions that we want to ask, because the OS is the one that manages the resources and the processes behind a Flutter app or an Android application. So let's see exactly what Flutter offers us to be able to do this. So basically here we have two classes that only have static methods that tie to the native side of the Flutter. So the first one that you see here, the callback handler, basically what it does, it registers a method, a top-level method or a static method. It registers that method and gives you a raw handler for it. So it's basically an integer that you can use to access that method from different threads, or in our case, in Dart's case, from different isolates. So if you're in a different isolate, you could use this value that the callback handler gives you, and you can call that method. And this is very important, because we talked about the fact that to be able to run code in background, we need the OS to allow us to do that. So in Android's case, to be able to do background stuff, you need a service. Now a service is very different from the application. So when your application is actually closed, your service can keep going. And that means that the isolate that you're starting your application from is different from the one that the service needs to run. So this method is very useful because it allows you to call a Dart method from a different isolate. Now the second one that you see there, from the isolate name server, allows you to communicate with a send port with other isolates. So what you can do there is to create a send port that you will send or register with this method. And then on the other isolate, you can look it up. And then you can communicate. You can basically establish a two-way communication between isolates very easily. So this is what Flutter gives us to be able to do that. But at the end of the day, it's, again, our job as developers to communicate and to behave properly with the OS that we are hosted on. So this is actually what we're trying to do. Let's go to the fun part. So live coding. Are you ready? Hopefully everything will work. And we're going to see how we are going to use those tools to do exactly this, to be able to call background code from a service. And let's see the result type that we are trying to build. Okay, perfect. So what we're trying to build here would be an application that will allow you to record yourself, to record your voice or whatever you want to do, your thoughts, if you think out loud like me. And this will work even if you close the app. So let's see how that works. This is a very simple application. The first thing we do, we start the service, the foreground service. So now the service is start up. And I can do whatever. So what I can do here is close the app. The app is still here. The service is still here, actually. Then I can start recording myself. And I can open the app again. The app will know that I'm recording right now, so I can save or stop the recording. And if I save it, then the recording has been saved. So basically, this is what we're trying to do. Closing the app will not kill my process, and I can continue to do my work even if my application is closed. So how do we do that? So we saw earlier that we need to have a top-level function or a static function that we want to call or to be able to call from background. And in our case, it's going to be this function here. So we want to call the background function. This one will be the code that we are actually executing in the background. So let's see how do we do that. So we said that we have, the first step, we said that we have that method that we could use to get the handler of that specific function. So basically is plugin utils, get callback handler, and we would need to give it the method name. Now, it's very important here that we actually give it a static function or a top-level function, because otherwise it's not going to work. So if this is false, if this is not a top-level function, it will give us null. So it's important to keep that in mind. So let's call it handler. Now, the second thing that we want to do with this is to actually register a send port. So for that thing, we're going to use the second method. So isolate name server. What do we do without auto-completion? And we have register port with name. So again, what this method does, it takes a send port and then registers it with the Flutter engine. So you could use it from a different isolate. So we already created the receive port. In this case, we'll only have to give it the send port. Let's give it a name. This name is used to look it up from the other isolate. So let's call it foreground. So why do we need that? So we want to be able from the background to communicate with the front end once we have the isolate set up. So we have the handler set up. We are registering the send port, and now we want to start the service. Now the service in our case, to be able to start it, we need to invoke a method that we're going to implement in the Android side. So let's do that. So it's a start method, and we want to give it 2 parameters. I'm going to see in a bit what they do. So basically, we need to give it the raw handler. So that would be handler to raw handler. This is like an integer. And then we need to give it the path, so where we want to save this. Let's put a bank operator here to make it work. And what we want to do here is to, once the service is started, we're going to start the background execution. So that will be the Flutter engine. And that Flutter engine needs to send us, a feedback that, hey, this background is up and running, and you can do whatever you want. You can start calling methods on it. So we're going to see how we do that. So what we need to remember here is the two functions. So get callback handler and register port. These two methods are very important because they allow us to create this inter-isolates communication and allows us to use Dart code from a service, basically. So let's see the Android part. So we registered the callback, we registered the send port to be able to communicate back with the front end, and now we are starting the service. So let's see how that works. What we need to keep in mind here is that obviously there's a bit more code here, but at the end I'm going to give up the repository so you can actually have a look at this. Yay. So this is a normal service that I register here. The method call is very simple, what it does. So the start method is here, creates a simple intent. If this would be bigger, okay, good. So it creates a simple intent that puts the two values that we sent. So the callback and the path, and just starts the service. So nothing too fancy here. Now on this side, this is where it gets interesting. So how do we start the engine, the code, right? How do we get the handler how do we use the handler that we just got to start up the function? So we need to look it up. So there we actually get the handler, and now we need to look up the handler. So it's going to be Flutter. Forgot the name of that, but I have it here. Thank God. Okay, Flutter callback information. Okay. And this has the opposite of what you use in Dart. So look up callback information. We give it the handler. So this is like the integer that we received. And what this contains is basically the address of that method that we can call. So the information here is basically where is this saved? Where is this background method saved? And what do I need to do? What do I need to know to start it up? Now the second thing that we want to do is to create a Dart callback, which is basically the entry point for the Flutter engine. So let's see. So it'll be callback. And what this needs is like the asset manager from Android. Then we need a path bundle, which is basically where all the assets are saved. And then the callback handler, which is in this case info. Oh, sorry. No semicolons. Okay, and this we got it from real quick. Okay, yeah, it's a lot. Yeah. This recently changed. So Flutter injector, instance loader, and then app path. Okay. So now we have the callback. Again, this contains all the information needed for the Flutter engine. to basically start executing that code. So let's create a Flutter engine. So what do we need here? The context. The service is obviously a context. We can give it. And then we need the ladder. So it's going to be null in this case. We don't need it. The arguments. And then we say engine execute dart executor execute dart callback. Okay. So this is basically it. This is how we start the engine, and with this code, what will happen is that this method will start running. So as soon as we launch the app and we register the service, this thing will execute the background method. And let's test it. So let's put a print statement here and run it. Let's give it a run. All this initialization stuff is pretty common when you try to add Flutter to your application. So you already have an Android application. You want specific screens to be in Flutter. So this is very close to what you would do to have this kind of a hybrid application where you have both Android and iOS. Okay, so we have this. Let's see, start. Okay, that's good. The gods are with me today. But even if it crashed, I think we should still see it somewhere. Not initialized, right? Okay, let's see. Let's debug this. Okay, 124. Okay, so, okay. This is, okay, yeah, here. Let's comment this out. Okay, we are in background. Yay. So what we did here is that we started a foreground notification with a foreground service, and that thing starts a different Flutter engine. That means a different isolate, which is actually running at the background function that we just created here. Okay, so what do we want to do? So we said here that we need to tell the front end that we initialized and we are ready to receive calls. So how do we do that? We actually send a send port here, right? So we can use this send port to notify the foreground that we are ready. So how we do that? We use the opposite of this function. So we have register port with name, and then we're going to say isolate name server, look up port by name, and then we're going to use the same name. And this will give us a send port. It's nullable, yeah, because it might not be there. But in this case, it's there. So we're going to say port, send. I'm going to just send the null value. Now, what this will do, let's see what happens with the send port that we created. So the send port that we sent here is actually attached to this port, and this port has a listen on this method. So what it does, when the message is null, so when we receive null, it will say that the service is registered, and it will complete the completer that we are using here. So basically, we're just going to say await completer, future, and then we say that completer is null, that we are up and running. Okay, so what did we do? We started a service. The service called our background method, and we informed the foreground, that we are ready to receive information from either the notification or the app itself. So now what we want to do here, the next step, we should add this back. What we want to do here is to be able to inform the background about the notification. So if the user clicks on an action in the notification, how do we tell the background to do one thing or the other, to start the recording, to stop the recording? So to be able to do that, we're going to use a method channel, but this time the method channel is going to be on the background, because we know that all method channels that we use in Flutter are actually running on the main isolate, but if the app is closed, that's gone. So how do we do that? So in this case, we want to create a method channel that actually works on the other engine that we created. So basically, at the same time, in our application, we have two engines. So let's see. Let's do a normal method channel. So method channel. This time, it's going to be engine.dart executor. So what this tells, what this does is that instead of creating the method channel on the main isolate, we're going to use the isolate that we just started on the background function. So let's give it the same name. Okay. So in this case, we're going to come back here and then create the other end of the channel. So we created a channel. Now we need to send the path as the argument. So we're going to say invoke method path, sending the path where we want to save the audio. And in here, we have also Boolean. Sorry. We need to make it true. That the service has been initialized, it's ready to receive information. Okay, so now what this enables us to do is that every time that the user taps on the actual notification, something is transmitted to the background. And to be able to do that, we use this method channel. Now, on the implementation side of the Dart, we need to listen to those methods. So let's do the same thing. Create a method channel here. Give it a name, which is background. Can make it const. And then we can set a method callback handler. So let's see what happens. Let's put a sync. The return type of this is future. Okay, and let's print. Let's see what happens. Okay. So this time, the difference is that we are telling the foreground, we are ready, we can receive information or instructions to do something in the background. And then the second thing that we did, we created a channel of communication between the service and the actual background isolate. So let's see how this runs. What we are expecting to see here is that as soon as the engine starts, we will get back the path where we want to save the file that we are trying to record to. Okay. Okay. Oh, okay. So what did we forget here? So every time we try to call a method channel without calling ensure initialized, it will not work. So what we need to do is to say Flutter, widgets, binding, Flutter binding, ensure initialize. Now it will work. Let's see. Easy to forget. Good. So what happened now is that we actually saved the state that was previously there, that the service is started, but it was not actually started. So that's why we need to do some small changes here. I'm actually using shared preferences to make sure that the state in which the recorder is persisted. So if you close the application, you still know. Obviously, this if you have like a state management solution that also persists the state, that will be even great because you can manage that state. Because in this case, you're going to have like two different. You can think about having two different applications that need to be synchronized. So it's very important to do that. Okay, so let's see now. Okay. Okay, so what we have here is, let's see. Yeah, method state was called with the new value. Okay, so let's go further. What we do here is we need to like implement the, we want to implement the rest of the method calling channel. So that would be call method is path. When we are sending the path, we want to just save it here locally. So it's going to be path call.arguments. This is what we are sending. And then further, what we want to do is to just use the send port to communicate with the front end in case the application is open. So that would be port.send. And we're going to send whatever state the application is in. And as you can imagine, from here you could drive your own implementation in terms of what package you're using for actually recording the audio, if you want to have like pause, stop, or whatever.
So quick question. So at this point, everything as normal in Flutter works?
Yes. Yeah. And there is this communication already set up from the both isolates and also with the service that is running. So the main thing, or the source of truth, needs to be the isolate, the service, because that's the thing that is going to outlive the application. So yeah, that's the source of truth. So even if the action comes from the notification, or you actually send it from the application, you need to go through the service to be able to, so you know that you keep the state. Otherwise, it's going to be a mess. So in this case, the source of truth is always going to be the service.
Another quick question. How do you know that, for instance, the isolate gets killed or the service gets killed?
Very good question. Very good question. Thank you. So it's very important to kill it, because otherwise the system is going to kill it for you. The good thing is that foreground services, if you want to start a foreground service, you are required to have a notification that is persistent. So basically, as long as the notification is there, their service is still working. So you need to provide the user a way to stop it, or for you to stop it whenever you think it's reasonable. So in this case, there is a method that we have here. So if you start it, okay, then I can stop it. That's a crash, but but you could you basically, what you do is you tell the service self-stop, and that's what actually kills the service.
So you have to notify yourself if you want.
Yes, you need to do that. Otherwise, the notification will stay there. Also, the user can close it. If like they hard press on it, long press on it, they can go to stop, force stop, and that kills everything, whatever, no matter what you do. But basically, how that works here is that it removes the send port, so we no longer receive information from the background. And then what it does, it calls the stop method. And this, in turn, gets here in the service, the stop. And what it does is this. So destroy the engine, basically killing the isolate, and then stopping the service. So this is what it does. Now, to recap a little bit what we did here is, as I said, we used two tools here. Get callback handler, which registers a function, top-level function, a static function that you can use from a different isolate. As we know, the isolate stuff in Dart, you cannot send whatever you want. The memory is not shared between isolates, so you need to somehow be able to communicate or to call other functions. So this is like an integer, and it's easily sent through a send port. We used this in the Dart side, in the Android side, to actually start our engine. And we created an engine, we give it the function information, and then we run it. At the same time, we created a channel that runs on that engine. And then when we were in background, we used the register port name here in this function to be able to tell the foreground, to communicate with the foreground on a send port. So obviously, this is like a super advanced use case, but you might come over it. And this is also in the case that you need to actually show something to the user. If you just want to do a background task that you want to schedule overnight or when the device is plugged in or has internet connection, you can use background tasks. There is a very cool library for this. And it's easy to use, but the principles behind them are the same. A bit more stable than mine, that's for sure. But the principles are the same. You need to have like a top-level function or a static function that you could use to be able to do whatever work you want to do in the background. This, what we examine here, I think, is the hardest one when you actually need to like do notifications. So to be able to change the information and whatever the user sees. So as you can see here, we have some pending intents and a lot of Android stuff and notification building here. So to be able to inform the user about the proper state of the application and what they can actually do at that stage in the service lifecycle. I'm going to send you the repository at the end of this meeting. You can actually have a look at it. And the thing is that when you are in this kind of situation, there is not an easy way of doing it. But it's not the fault of Flutter. Flutter is just like on top and needs to obey all the rules of the OS. So we need to say, pretty please OS, run this code for me. And we need to obey to all the rules. For example, on iOS, it's even worse because you cannot do this kind of implementation. If the app is killed, you like swipe it off of your activity. It's killed, so nothing goes there. Thank you very much for attending this talk. If you have any questions.